Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Ev Haus, who is the head of technology at ZenHub, based in Vancouver, Canada. Ev Haus, welcome to Maintainable.
Thanks for having me. I'm pretty excited to do the podcast.
Well, I'm glad to hear that. Let's dive right into it. So given your experience in our industry, what do you believe are a few key indicators that a software code base is being well maintained?
There's quite a lot that has to do with what I would call a good, maintainable code base. I mean, probably the big piece of that is just the amount of tech debt that you have to kind of deal with from a daily basis. And tech debt can be kind of defined probably in a few different ways. There's a lot of different people that, I define it in several different ways. There's a few people on your podcast that have mentioned it. Some people call it, things that maybe prevent you from being able to develop quickly. I also think it has to do a lot with confidence. So a really good maintainable code base is something that you have confidence with. The way that you can think about confidence is how easy it is to actually ship something from your code base. How quickly are you able to release something? So I think for me, like a really good maintainable code base is something that your entire team feels confident deploying on a very regular basis. You should be having releases potentially even multiple times a day. So I think to me, that's probably the way that I would see that. All
right. And how do you and your team at ZenHub define technical debt versus, say, just shitty code?
Yeah, I thought about that a lot. Because there's a lot of things that get in your way. There's a lot of things that make you not be able to move quite as quickly. But technical debt is, I think, it's a little bit more nuanced than that. Like, I guess one way I can think about it is, like, let's imagine you own a house, right? And it's springtime. Maybe your wife asks you to clean the gutters. So you bring out the ladder. You start, cleaning stuff out. Maybe you get some buckets out. You wash the car. And you leave all of that stuff out there. Around the summertime, you got kids, they're playing with all these toys. Maybe they're riding their bikes. They leave all of that stuff on the driveway. And, by the time winter rolls around, it starts snowing, kind of covers up all of the stuff that you've left in your driveway. And then maybe one day there's a massive blizzard. And then so it kind of forces you to start, cleaning your driveway. And now you're in a bit of a pickle. You kind of start to clean some of that, just start shoveling the snow. But then you start to discover all this stuff that you kind of forgot behind, right? You got these bikes, these ladders, this like weird bucket that you've left behind. And all of these things are preventing you from being able to move quickly. Like your job is to get rid of the snow and all of this stuff is getting in your way. So that to me is technical debt. So it's the mess that you've left behind. And what makes it worse, like with the snow example, is that you don't even really know what's under there until you start digging, right? And it's very much the same with technical debt. Often technical debt piles up and you forget about it. And by the time you get around to it, it's very hard to remember what you actually got under there. And, a lot of the times, people on my team will say, well, how long is it going to take us to fix this piece of technical debt? And it's really hard to answer that question because until you actually get your hands dirty, you get in there, you start moving stuff around, you don't really quite remember what's under there. And I find it's very strange that we find ourselves in the situation often, as kids, we've been taught, to clean up after ourselves. It's, one of the very first lessons our parents teach us. And I find that the same thing should be carried forward with us into adulthood and especially into working with code bases. So that's a really simple way for you to kind of avoid getting into the situation simply by cleaning up after yourself after you do any kind of simple project or simple task.
Yeah, that's an interesting way to kind of describe that. I'm thinking about the scenario where there's some developers or let's say renters of a house that move in the middle of the winter and don't realize that underneath all that snow is a bunch of things that the previous tenants had left there and you don't know why they're there.
Yeah, exactly. And it's really strange as well because we continue to procrastinate and it's only until there's maybe a massive storm and the snow plows are coming and getting in your way and it's just everything is working against you and we wait until the worst opportunity to deal with it. And that makes life even more harder, right? So you're inflicting pain on yourself just by waiting.
Right. You touched on how it's difficult to estimate the amount of time or energy or resources it might take to, say, clean up some of that technical debt. What else do you believe developers often get wrong when they're discussing technical debt with one another?
I honestly think the solution to technical debt is probably the thing that people get wrong the most. Even on my team, like we talk about that a lot in terms of, okay, what are we going to do? How are we actually going to solve this problem? One of the things that I tried throughout my career is different companies call it different things. Some people call it Platform Fridays or Tech Debt Tuesdays. But basically the idea is you set aside some time where your team can dedicate towards cleaning up technical debt or resolving some kind of pains or maybe writing documentation or developing unit tests or things like that. So it's a set amount of budgeted time that you put towards resolving this sort of stuff. And I've kind of had mixed results of that approach because you have to be very diligent about it. You have to actually make sure that people have this type of work to do. You have to make sure that the company is on board with you dedicating this time to it. It's a very political game. And I've found that doesn't work quite as well. I mean, it's just because I think the problem is that not everybody's quite as ambitious of a developer in terms of technical debt cleanup. Like on every team that I've ever worked with, there's always at least, one developer who's really passionate and who's really frustrated with the amount of technical debt or even, around some of the architectural decisions that you might have. And I think one of the ways that you can kind of help your team is to recognize those key people on the team and to encourage them as opposed to, kind of not necessarily recognizing that their skills and their initiative in the area. And so I think a better way to address technical debt is rather than necessarily dedicating time for the entire team to address issues, is to rather recognize specific individuals on the team that are very passionate about that project, and then to kind of give them an opportunity to define a strategy or a way to solve it.
That's interesting. I think about how teams, there's some developers that really enjoy working on brand new things. There's other developers that like working on existing things. Not everybody gets to have the opportunity to do all those things all the time. What's your take on, like, if you imagine there's a team out there that has, let's say, 7 to 8 developers or something, and there might be 1 or 2 people that are really into refactoring and like taking care of dealing with these types of issues that might be kind of underneath the hood that may be slowing down the team. Do you find yourself as someone that heads up a team being nervous about making sure that we're often told as like managers to try to focus on people's strengths, but then sometimes we might start to not try to like push other people or maybe nudge them a little bit to kind of expand their skill set. And so you become very reliant on that, say that one person on your team to be the person that takes care of those messy things and makes them cleaner. And if they were to leave at some point, what is your team then doing at that point?
Yeah, I mean, that's always going to be a problem, right? So the idea of kind of siloing of information or siloing of skills, I think that's a pain point that every team faces. But I do think when it comes to technical debt, I think we can be a little bit more lenient in that respect. I mean, when it comes time to actually cleaning up the mess that somebody left behind, I don't know if the siloing of necessarily specific individuals is that big of a problem. I would consider that more of a problem, let's say, when you're developing new features or architecting new platforms or kind of building a new base on top of. You definitely want to have the entire team on board with that so that they understand how things are built and how they're structured. I do think when you're, you're trying to set a new foundation, that's when it's important for everybody on the team to be involved. But when it comes time to, clean up your lint rules or add tests for areas that maybe don't necessarily have them, or improve your documentation, these are things that not everybody necessarily needs to be a participant of, but perhaps people need to be a consumer of, right? So they need to see the final outcome. But I think I would probably, the way I would tackle it, and that I've had a lot of success with, is you sort of create almost like a task force, right? You get these volunteers in that are very passionate about resolving some of the pain points on your team, and you let them drive that forward. And that I found works really, really well.
That's great. Some great suggestions there. Do you believe software can ever have zero technical debt?
Absolutely. I mean, I've worked for a long time at a company that had, I wouldn't say zero, but it was so marginal that it was barely noticeable. Like every day you would come into work and you would feel excited about working on the code base because everything was there in a way that is well architected and there was very little stuff getting in your way. Now, having said that, I was the principal architect on that project, so my opinion is very, very biased. Maybe other people on my team thought it was, a horrible mess. But I do think it's not very likely, just given the fact that, you talk to your team all the time, right? And you get to hear about some of the pain points that they're having. And you get to hear from your customers in terms of what kind of bugs that they're seeing, right? So if you're seeing a lot of bugs, or if it's really hard to ship something, or if your tests are failing all the time, or maybe you don't even have tests, all of those things are signs of a good, maintainable, clean code base. So I do think it's possible to get there, but it takes time. And I'd love to get into like some of the things that I would define success look like.
Okay, great. We'll come to that in a moment. But for those that might not be familiar, what is ZenHub?
Yeah, absolutely. So ZenHub is a project management suite that's integrated directly into GitHub. So I'm sure most of your listeners are familiar with what GitHub is, and they probably spend a lot of the time in there. And you might not know, but actually a lot of enterprise companies use GitHub themselves. And typically when it comes time to managing your tickets or tracking your work or running sprints, a lot of teams leverage other tools other than GitHub because their task management system isn't quite as robust. And this is where ZenHub comes in. So we integrate very, very deeply directly into the GitHub interface. And it lets developers stay in the ecosystem that they love, which is GitHub, and continue to do all of the work that they need to do directly from there.
That's great. And as a small disclaimer, I use it for one of my open source projects. Well, I should say one of my co-maintainers suggested that we use it. And so they primarily use it, and I work with it. And it's been a great tool to use for even those types of projects as well. So we're not using it on any of our client projects at the moment, but we do use it for one of my open source projects that we have a lot of tickets in there to manage. So it's been great. That's
fantastic. Yeah, I'm happy to hear that.
And I also hear that recently ZenHub released a feature called ZenHub Roadmaps. And what does that offer?
Yeah, Roadmaps is quite a fantastic feature. So the main advantage of having all of your data tracked within GitHub is you stay really, really close to your development team, right? So all of the work that your developers are doing is tracked inside of GitHub. And so you have access to very raw, real data about how your team is doing, what's the progress of your tasks, how are we doing against our estimates and things like that. And by integrating a roadmap directly into that data, we can surface all of that information up to the leadership team at your company. So they can not only plan the work that they have coming up ahead in terms of high-level goals for your team, but they can also track the progress of those projects directly within GitHub. It's quite amazing. So once you have it all configured, it gives you a very powerful view into how your team is doing at a very high level.
Nice. I'm going to have to check that out. And we'll definitely include links to that in the show notes. So as the head of technology at ZenHub, what are a few metrics that your team is measuring?
Yeah, so there's quite a few metrics that we've put into place. Some of them I would say I'm happy with. Some of them I think are still a work in progress. Some areas that I look forward to is just the speed of your team. So how quickly are we actually able to move? And what that means is how quickly are we able to commit code? How quickly are we able to ship releases? How long does it take for our PRs to get reviewed? So anything that has to do with blocking your team from being able to deliver results, all of these things are the types of things that we measure. And we want to see those things improve over time. Both in terms of, as the team grows, those things should be getting better because obviously you have more people to contribute to. But also even with an existing team that maybe doesn't change very much over time, you want to see those metrics improve. And the way that you see them improve is by investing into infrastructure, right? So you invest on tooling, you invest in automation, you invest in testing, you invest on all of the things that give your team the confidence to be able to ship very quickly.
You touched on a few things there. One, like PR time for review. And I think I'm trying to imagine how I would even work with my own team on trying to attain some of these numbers. You mentioned also like how quickly people can kind of work or commit on projects. What sort of tools might you be using to capture that information without it being kind of a subjective? Well, I think like asking the team, like, what do you typically think it takes? How are you measuring that?
So at the moment, we will leverage a few tools to do that. I also do a lot of manual work to be able to track those numbers, I'll be honest with you. One of the tools that does it fairly well, I think, is a tool called PullPanda. It pulls data directly out of GitHub and provides you some high-level metrics on how your team is doing. The data that they provide is maybe not formatted quite in the way that I would like to see it. I definitely prefer to look at these types of metrics from a very high level, as opposed to maybe on an individual basis. Because obviously different developers will perform at different rates. They focus on different types of tasks. Some developers spend a lot of time, maybe just coaching or reviewing other developers. And so measuring people purely on, their throughput is not a really great idea. But I think measuring teams on throughput is a good idea in terms of giving you an idea of how quickly you're able to get things done. Because at the end of the day, that's what really matters, right? It's delivering stuff to your users.
That's great. And I would imagine that a lot of the data that you might get out of something like PullPanda is are lagging indicators, right? Versus like leading indicators. And have you been able to come up with maybe that speaks to some of the manual work that you might be doing into any leading indicators about what's coming up for the development team so you can kind of anticipate potential problems?
Yeah, leading indicators are really hard in software development. I haven't really found anything yet that I would, put my faith in. So most of the time I'm spending analyzing historical data. But even with the historical data, it gives you a really good sense of what has worked and what hasn't. So, we do a lot of experimentation on the team. Like we're a very open-minded team where we try lots of different things, both in terms of technology, like we'll play around with different tech stacks, also in terms of process, like we'll try Kanban for, a couple of sprints and see how that goes and switch over to Agile. And then, we'll do some mixtures of these things. And so even by just analyzing the data that you have, over the last few sprints, you can get an idea of how things are changing on your team as you go. But I would love to get to a point where we can do some leading indications. Today, we're not there.
Okay. One of those things I'm always curious about. So if anyone out there listening has some good suggestions, I'd love to talk to them about that at some point too. So, we're talking about how companies or teams might be able to work towards attaining something close to or even reaching zero technical debt. And you kind of hinted at there might be some topics there you wanted to touch on. What are some of those things that you can see in a team or that one project you had previously mentioned where you were able to get to that point? What did you have in place?
Yeah, absolutely. I think there's actually quite a few things. So let's see if we can kind of get through some of these. I think the biggest thing that's going to set things apart is to build that solid foundation. So one of the things that I deal with a lot is, it's quite scary. You might be joining a team that has a lot of technical debt. Like, for example, ZenHub, the product evolved very, very quickly, right? It started as a very simple like button on an issue page and evolved into this massive project management suite that now powers very large enterprises. And that happened within, just a couple of years. And so when you join a situation where you already have a lot of technical debt, it could be quite discouraging because you don't quite know where to start. And I'm a big fan of starting at the very bottom. Start as if you have a very clean code base. What are the things that you would want to have on a fresh green project? And start with those. And so for me, those are things all to do with automating various types of tasks. So for example, I think that one of the biggest pain points that I think most teams face is managing their third-party dependencies. So all of those libraries that you're importing. So how do you deal with those? How do you keep them in sync? How do you maintain them? How do you version them up? How do you deal with security patches and things like that? Most companies I know deal with this by kind of addressing it on a case-by-case basis. And I think that's a terrible approach. And I think that leads to a lot of technical debt. And so the approach that I've taken, and I found that works really, really well, is to literally every single morning upgrade all of your dependencies. Give that task to one of your developers. They will go through all your dependencies and try to upgrade them, every single one of them. And some of those might go through. Some of those might be really easy. Some of those might be really, really hard. And if you come across a really hard one, like, I don't know, let's say your project is written in Python 2 and then Python 3 came out. And I was like, oh my God, this is going to take us forever. That's okay. So at that point, what you can do is you can make a note to your team. Hey guys, Python 3 is out. We should consider upgrading. Here are all the things that are going to be a problem for us. But the difference is that you find out about it at the very beginning. You find out about it when, the alpha ships, not when that project is reaching end of life. So by dedicating time every single morning to these types of tasks, you actually don't end up ever accumulating the technical debt. Instead, you become very proactive in terms of resolving some of these things. So that's just one of the kind of the strategies that I use. And actually, a lot of my personal projects, even like what I'll do is there's a lot of great tools like Dependabot or Greenkeeper, Renovate. These tools will literally just automatically send you a PR whenever a dependency upgrades. And you can even, if you have the confidence and the right amount of testing, you can even just have them automatically merge those in. All of your dependencies automatically upgrade.
Assuming the test suite.
Yeah, that might be a bad idea for, companies that, might be a little bit more security minded. Like maybe if you're working on a bank or crypto project or something like that, you might need to be careful around, people injecting stuff into your packages. And yes, you've hinted on a good point. Like having a good set of automated tests is definitely a prerequisite to this.
So as an initial step that companies can take or teams could take is to have someone on your advice being almost, pretty much daily, starting off a day, having someone be responsible for going through all your dependencies and trying to see if there's anything that can get updated and make sure the build still passes and such. And I think I hear you on that because my team, we inherit a lot of projects. And so it's usually the first things we do is it's like, all right, so how far back is this piece of software on all the other dependencies? And that usually becomes like a pretty big project in and of itself just to navigate through all that. So if you're doing that on a regular basis, I would imagine then you're only dealing with a few small updates every day, if even that, versus, if you do it like every once or once a quarter or every 6 months or something, and then you find yourself being like, all right, we got like 30 dependencies that we need to deal with. And then that's a really big project probably to wrap your head around. It may or may not be a priority for your other stakeholders to deal with that in contention with like some whatever else might be in your backlog right now.
Yeah, that's exactly right. And testing is a really big part of that, right? It's like that's what gives you the confidence to be able to do these types of things. Like, let's take a project that you might be working on and ask yourself the question, if you were to rewrite this entire thing in a different language, how scary is it? If it's incredibly scary, you probably don't have enough tests, or you don't have the right type of tests, or maybe your code is too monolithic, which is something we can also talk about later. But you should be able to, build your application, build your software in a way that makes it very easy to change it. And testing of all different types, unit tests, integration tests, end-to-end tests, all of these things contribute in their own various ways to help build up that confidence.
Speaking of, testing and maybe relating it back to, third-party dependencies, when you're integrating, let's say, some sort of external open source library, for example, how much testing do you feel like you need to do? Where's that line you feel like you and your team are able to draw between what you're testing and how you're interacting with let's say, the API of that dependency, and also then relying on the open source team to make sure that they're doing a good job of testing their own piece of the software of their library? Where do you find like a good intersection is that you would recommend to people to make sure that they feel confident that way you're using it isn't broken, even though your build's passing, but maybe there's something actually within the library itself that may or may not be working the way you expect it to anymore?
Yeah, that's a really great question. And I don't know if there's a very easy answer to that. I think it truly depends on the project that you have and the types of dependencies that you use. It definitely is something that my team has struggled with a lot in terms of, okay, what types of tests do we need and how many do we need? I know some teams that are very strict about that. Like, for example, you got to have, 99% unit test coverage before any PR gets approved. And I do believe that helps, but I don't know if that's necessarily the best metric to use as a hard rule for your team. Unit tests are really great at catching issues when you're refactoring some code, but they're actually not that great at catching, mistakes in third-party packages, because third-party packages usually kind of sit so low on your tool chain that these types of things will slip through. And so for that, you need different types of tests. Maybe like integration or end-to-end tests would be better at that. And that's kind of what I was mentioning, is like you need a plethora of different types of tests, not just a focus on a specific strategy. And let's not forget about manual testing as well. Like, we've just on the ZenHub team, we've recently hired a sort of like a head of QA, and their job is primarily to think about these types of problems. Is like, what types of testing do we need? Where do we test manually? Actually running through a lot of our manual tests. And all of that really does help contribute to the confidence of the team and to allow you to be able to do these types of automation strategies.
Early you had touched on or hinted at projects becoming too much of a monolithic in nature. What do you mean by that?
So that's one of the things that I think is more of an architectural thing that you can do on your team to help avoid technical debt. And that's all around building small modules or microservices, let's put it that way. Microservice architecture has been discussed a great deal on a lot of different podcasts and a lot of different articles. But I do think the idea of building things in small reusable pieces is a very valuable one. And it's definitely one that helps reduce the pain of tech debt. The idea of microservices is purely thinking about everything as a black box. Like, you define an API for your input, you define an API for your output, and whatever happens in the middle is none of your business. Like, it can be written in completely different languages. You might have a company that maybe even uses like 4 different languages, and they write different microservices and all sorts of different tools and stuff. It really shouldn't matter what happens inside that box, as long as the inputs and the outputs are well defined. And most of the times when people think about such architectures, they typically think of backend systems, because that's where you would primarily find this sort of stuff. But I do think it also applies to front-end architectures as well. So the idea of, like even pure functions to me is a type of microservice architecture. The idea that you have a very controlled set of APIs that govern your entire code base. And kind of that's what I mean, is when you architect things in a way that makes it very easy to take a component out and then put a new component in, that makes your technical debt, pain quite a lot smaller. Now, it does mean, however, that you have to invest quite a lot more in tooling, right? So in order to design these types of architectures, first of all, they're harder to come up with. They're quite a challenging sort of brain puzzle, but you also need certain tooling in place. Like, for example, like Docker containers are a great way to encapsulate these sort of things. And, using tools like Kubernetes or Docker Swarm to deploy them. You might have to invest more in your CI/CD pipeline to ensure that you can deploy these types of systems easily, because when you have a lot of small pieces, that's a lot of stuff to manage and a lot of stuff to deal with. And that could be challenging. So you might even actually need to hire a dedicated DevOps person just to facilitate this sort of thing. But I do think these are the types of strategies that definitely help reduce the pain of monolithic architectures.
I personally don't have a lot of experience with like some of these more larger environments where you have a lot of microservices and you have a lot of different teams maybe managing different aspects of that. For those that are listening that maybe are working on smaller teams, do you feel like there's a point when it makes sense to start breaking things up when you're building? And you mentioned like how ZenHub started out as maybe a like button on repositories. It became this project management suite over the course of a couple of years. Do you feel like that was something that was a mistake that they didn't break things up earlier? Or is that just something that you need to take care of once maybe you're kind of reaching a certain scale and you go, okay, how do we rethink what we're doing here?
Yeah, I would say it was probably a mistake, but I think it's a necessary mistake, right? You're going to make mistakes as you develop your software because you need to be able to move quickly. You're going to be making a lot of decisions based on information that you have at the time, and that might not be the entire information that you have, right? So I think it's okay for teams to make a mistake and then to go back and, split things up, refactor them, address things. That's a natural evolution of any software development project. But the important thing is to be able to recognize these types of things. Recognize when things aren't working anymore. Recognize when things are slow and difficult. Recognize when it's really hard to change your code. Recognize when it's really hard to deploy your code. All of these things are signs that something isn't quite working in your architectural decisions. And that's usually a good opportunity to take a step back, think about what do you have? Why doesn't it work? Where are you going to be, a year from now? And then to architect around that. And those are good opportunities to start maybe thinking about microservices architecture if you don't already have one, in the sense that you should be able to encapsulate small chunks of your code. One of the things that I really like to tell my team is focus on developing code that's easy to delete. Like, to me, good code is code that you can be easily deletable. And what that means is usually is that things are isolated and you can remove any one piece and replace it with another piece.
I like that idea. Good code is easily deletable. We'll be back with our interview with Ev in just a moment. Hi, it's me, Robby. I wanted to take a quick moment to thank you for making time to listening to Maintainable. If you're finding these discussions valuable, please consider sharing a link amongst your peers and writing a review on Apple Podcast or Stitcher. Also, if you know someone in our industry who I should be speaking with on Maintainable, shoot me an email to Robby with a Y at maintainable.fm. And now, back to our interview with Ev Haus. I know another thing in one of our previous conversations, you were talking about good pull request etiquette. And I want to discuss that a little bit, mainly in thinking about both sides of that. So what do you think is important for developers when they're going to open up a pull request to consider? And then maybe it'd be nice to talk about what it's like for the other people that are going to be reviewing someone else's code. And then maybe even take another further step is how to receive feedback as that original submitter.
Yeah, absolutely. I mean, pull requests are, the bread and butter of any developer. These are the units of work that we deal with on every given day. So it's important to have good pull request etiquette. So for me, so I think there's two sides to it. One of it is a focus on readability, and the other one is the focus on ensuring that every pull request thinks about gradual changes. So let's talk about readability first. I'm actually, and this is going to maybe potentially be highly controversial, but I actually think dry code it's a bad principle. And it's very strange because it's one of the very first principles that they teach you at school in terms of not having a lot of repetition in your code. I actually think repetition is really quite good. Repetition, more often than not, makes things easier to read and easier to follow. And code duplication is not your enemy. Like, your enemy is readability. Your enemy is making things easy for other people on your team to understand. A really good mark of a good coder is you should be able to give that code to the most junior developer on your team, and they should be able to review it and give you constructive criticism and feedback on that PR. No matter, if it might be the most architecturally complex piece of code, but if it's written in a way that's easy to follow and easy to read, that's quite important. I'm actually personally a very big fan of things like very strict linting rules and actually being very strict about how you write your code, because I actually think the idea of, having consistent code from one developer to the other is important. But I know that's something that, a lot of teams don't necessarily agree with. But one of the things that I think is important is making it easy for your code to be readable top to bottom. You should almost be able to read it as a book. And if it isn't possible to do that, it's likely because you may be having different abstractions that you might not need, or you made it overly dry. One of the phrases that I really like is so dry that it chafes. Or perhaps what you've done is maybe you didn't have enough documentation. Even little comment snippets in your code sometimes are very important to make things very easy to follow. All of the PRs that I try to do always think about the reader in mind. Not even necessarily the user of the code, but the reader of the code. You want to make things very easy to be reviewed because, again, it all leads to things being easy to ship. When things are easy to get released, your team is able to move quickly and it's able to satisfy your customers more quickly, and ultimately leads to more successful companies. So that's kind of the first side of it, which is, focusing on readability of your PRs. But the other side of it that's also quite as important is to always think about making things gradual. You want to be able to deploy your changes in a gradual way, even when the project is quite large. Like, for example, let's say you're given a task to refactor a large section of your code base, and perhaps that code base is very monolithic and it's really complicated. There's a lot of, interdependencies and complex spider webs that you have to deal with. A mark of a really good developer is somebody who's able to find a way to deploy it in a gradual way. And when I say gradual, I don't mean file by file, because that's actually when you break up your work file by file, you've actually just introduced even more technical debt, right? Because you got to go back and clean up all of those files that you've left behind. When I say gradual, what I mean is to carve the problem up into the problem statements. So rather than solving all of the problems that you're trying to solve, find a way to solve a small part of the problem, but across your entire code base. Every PR that you should do should always basically cover your entire code base. So let's say, for example, maybe your task is to change how you manage dates inside your application. And you were using maybe one library to do it, and now you want to switch to another one. An inefficient way to do that would be to, say, okay, I'm going to fix it in this one file, and then all files moving forward, we're going to use the new way to do it. We're going to use the better way to do it. And then we'll deal with the old stuff, as we go along. I find those types of strategies don't work at all. In fact, what you've done is you've introduced even more technical debt. Now you have two ways to do things in your system. So a better way to do it would be to change your entire code base to use the new method. But perhaps what you do is you sidechain some of these functions to call into an older system if you can't do the entire project all in one go. So basically what you're trying to do is you're trying to carve up the task into a way to make wide sweeping changes across your entire system, but not necessarily, have to spend an entire month doing it. You should be able to find a way to release this work every single week to keep your project moving forward.
That's great. And what sorts of advice do you give your team in terms of, so if someone submits a pull request and is thinking some of the, just the human aspect of this, what sort of advice do you give your team on how to respond and give feedback, and then how to also then receive that feedback as a submitter?
Yeah, giving feedback is really hard because you want to be assertive. You want to call things out when there's definitely a better way to do something. But you also don't want to upset your teammates by necessarily using the wrong wording or something like that. And that's a skill. That's a skill that takes time to develop. Just like a skill of, developing good code, providing good feedback is a skill you have to work on. One of the things that I'm a big fan of in my PR reviews is rather than telling somebody something, I ask questions. That's something I do in my career quite a lot when I'm trying to make an argument or suggest some ideas, is I ask a lot of questions. So for example, let's say I actually disagree with a particular decision. Rather than saying, hey, I disagree with this decision, here's a better way to do it. Instead, what I do is I try to ask questions to get the other person to understand the concerns that I have. So if I have if there's something I don't like about a particular architectural decision, I'll ask questions that challenge those ideas and kind of try to reveal some of the concerns that I have. So the point that I'm trying to get across is to be able to show the original author of the PR the types of questions that I'm asking myself as I'm reading through this code. And the reason why I find that strategy works quite well is because you're not the one solving the problem for them, right? You're not coming in and saying, hey, this is a bad way to do it. Here, let me propose another way. You're merely raising the concerns that you have and you're letting them discover their own solutions. And more often than not, they'll actually find potentially a better solution than you could have thought of. It's very rare that I'm the smartest person on the team, right? And so you wanna rely on your team to be able to solve the problems that you have. But people don't necessarily always see everything from the same angles that you do. And that's the whole point of PR reviews, right? Is that you're able to get the opinion from somebody else on the team, somebody who might not see things the same way that you do. So that's one strategy that I found that works really well. The other one is honestly just patience is probably the most important. And especially, when you're dealing with maybe new people on the team as well, who might not necessarily have enough confidence to work on certain areas of the code, or they just, they're not familiar with some of the tools or languages or structures that you have set up, is you need to be patient and maybe explain the same things that you've had to explain, multiple times before. You do it over and you do it over again. And through repetition, you build up both the respect on your team, but also you educate the people on your team as well.
Something you had touched on, and I like the phrasing here of, you're not coming here to solve their problem. And, as I'm reflecting on these types of topics come up in a lot of different teams that we work with, and, we'll see different styles of how teams communicate over pull requests. And the thing I think is kind of challenging for some developers, especially if maybe you're a junior developer, is let's say you submit a pull request for a small feature update and you get feedback on maybe it's very specific, like, oh, maybe I would have done it differently like this, or did you know about these other things, or maybe even ask some of these questions. At what point, who gets to decide in those scenarios? How do you as a team navigate that process? Like, all right, what happens if there's a disagreement in the approach? How does something move forward from that point where there's not just like, well, I guess we disagree that we're disagreeing on this, but lack of a better word, but who wins this specific pull request discussion at this point in time?
Yeah, that's really great. I mean, that happens literally on a daily basis everywhere that I've ever worked at. I'm a big fan of just shipping. The best way to find out if your solution works or not is to get it released, get it into the hands of your users, and see how it goes. Because ultimately, programming is an art in a way, right? There's a million ways to solve any given problem. And it's very possible that there are 10 correct solutions. And I think that's okay. And everybody on the team, I think, needs to appreciate that a little bit, in a sense that it's okay to ship code that you disagree with. The most important thing is to ship code that works. So I'm a big fan of, when there's a disagreement on a PR, is to lean on the author of the PR to make the decision about whether to ship it or not. Most developers are introspective, right? They appreciate good feedback. So when somebody challenges them on an idea, most developers actually appreciate that. They like the idea of there being different ways to solve any given problem. Now, at the end of the day, they may disagree with the approach, and I think that's okay. As long as the solution is solved, and as long as you didn't introduce a lot of technical debt, I think it's okay. You ship the code, you let it go out there, and you see what happens. And then, hey, if you were wrong, if it actually doesn't work very well, or maybe you did end up introducing technical debt, or maybe, I don't know, maybe it wasn't as performant as you thought it could be, or whatever else the disagreement was, That's okay. You iterate on it, right? And you make it better over time. You won't be able to solve all of the problems that you have in a PR review, because a lot of the problems don't surface themselves until the code is actually used in production. So the most important thing that you can do for your team is to keep things moving. Get those PRs out, ship them. If they fail, that's okay. That's what we have rollbacks for. That's what we have testing for. There's always an opportunity to improve. But if you're stuck, debating these things that might not necessarily see the light of day, you're not making things better for your users.
Do you have junior developers on your team?
Absolutely, yeah.
And I'm thinking about them in that scenario where they've submitted a pull request to see someone more senior and they get some good questions coming back or something. But do you offer the junior developers any advice on how to navigate that in terms of like, when is it okay for you to say, feel confident enough to say, I like to run with what I've got, this approach. We've gone back a few times, but I think we should ship it at this point. But I think there's always that dynamic of like, well, so-and-so has said to do it this way. So should I defer to them because they're more senior than me, or like it needs to be that way? Or where is that line for them to feel comfortable enough to kind of push something forward?
Yeah, I mean, that can happen quite a lot. Like you said, junior developers don't often have the confidence that maybe a senior does to make that decision. And so at that point, yeah, you might want to step in. If you're a senior developer, you might want to step in and say, you know what, this is good enough, or let's hold off on this a little bit until you have had a chance to refine it. In most cases that I've seen, it's very rare that I come across a junior developer who's so, arrogant and cocky that they're like, no, I disagree with this decision. I'm going to ship it anyway. I'm sure it happens on some teams, but in my experience, that's been very, very rare. So I think in the case when you're working with somebody more junior in the team, your job is to teach them, show them where you draw that line based on the feedback that you give them and where you make your recommendations in terms of when this is shippable or not. And then, you do that a few times, and then usually they're smart enough, they'll be able to pick that up. They'll understand what sort of, code quality standards that you have on the team, and then be able to make that decision better over time.
I think that's great. I think there's an overarching theme to our conversation has been about confidence, whether or not you're a junior or a senior developer, but also in just the process of getting the code that you're working on deployed and pushed out to production and shipping that so that you can actually see how it's going to work in the real world. So I just have a few quick last questions for you. One, slightly hypothetical scenario. Let's say there's someone listening and they're on a team and they don't have much of a test suite at the moment. Maybe I'm just being specific, an automated test suite. Maybe there's some checklists from QA checklists or something that they're working on. But beyond that, there's no real automated test for them to lean on. So some of these ideas that you have about automating dependencies and things like that, getting updated on a regular basis or having continuous deployment, what advice could you offer them on what types of tests they might find most valuable early on and where to begin that journey of starting to introduce tests?
So you've actually just described ZenHub. We're very much in the same situation. We've started, when I joined the team, there was very little in terms of automated tests. And we're just now starting to invest quite heavily in that. The way that we're going to tackle that is kind of very much what we talked about earlier in the show, which is starting from a good foundation. So basically, pretend that you're in a clean project. What sort of tests would you have in place? You probably wouldn't start with, very high level end-to-end tests. You probably would start with some more basic unit tests for testing basic functions of your applications. Start with the tests that are easiest to write, that might not necessarily give you the biggest bang for your buck, but they give you a solid foundation to build off of. And then kind of walk up the testing pyramid. I don't know if you're familiar with the testing pyramid, where you have unit tests on the bottom, you have integration tests in the middle, and end-to-end tests on top. You work your way from the base of the pyramid upwards. And the idea with that is that will inevitably cover everything in your code base from the lowest level all the way up to the top. And what I mean by that is I don't mean necessarily like fill out the base of the pyramid first and don't, do 100% unit tests as your baseline. Start with the easy stuff and then maybe sprinkle in some, integration tests in there. Start investigating, automating, end-to-end and UI testing in there. That might be an opportunity to consider manual testing and how does that fit into it. Should you be doing manual testing on every PR or not? Or maybe do you do it for an entire release? The idea of thinking about testing not necessarily just purely as a technical automation solution, but almost as a process, right? Testing includes people and it includes specific checkpoints in time. For example, even like when should you be doing testing? Should it be as you're developing a feature, or should you be following a more strict TDD approach where you write your tests first? All of these things are things you might want to think about as a team. And then you set some best practices in place, start working on those. But then again, don't forget that, one of my big recommendations is don't just do things right moving forward. Do things right throughout your entire code base. So if you're going to set a rule in place, like for example, let's say your team really wants to make a big impact on unit tests, and you set a hard rule around, 60% code coverage on all of our unit tests moving forward, or it doesn't get approved. Well, guess what? If you're going to put a rule like that in place, you need to go back and add at least 60% unit test coverage on your existing code base first. Otherwise, this rule doesn't really make a lot of sense, and it's actually not going to help you with your technical debt.
Well, with that, I want to kind of wrap things up. So where can listeners best follow your thoughts on software development online?
Yeah, I stay fairly active on Twitter, so you can find me at Ev Haus on Twitter. I have a Medium page where I, every now and then, will throw up an article around some of the thoughts that I have. So those are probably the two best places.
Well, great. Well, it's been such a delight having you on Maintainable, Ev. Thank you so much for joining us.
This has been fantastic. Thanks a lot for having me.
Maintainable.